Hi all, welcome to previous year GATE solved question paper series initiated by students of Civil Engineering Department at Christ College of Engineering, Irnalakuda. In this video, we will be discussing about the previous year solved questions from the GT1 paper. So let's move on to the first question. Soil is arranged face-to-face orientation. This type of soil structure is. The options are dispersed, cohesive matrix, honeycomb and flocculent. So let's discuss about each type of soil structure. First is honeycomb structure. This type of structure is present in fine sand or silt. When we use this type of structure for construction, the structure collapses and large deformation takes place under vibration and shocks. So in the right hand side, we have given the picture of honeycomb structure. It is clear that the shape of honeycomb structure is circular and also resembles the honeycomb. So if we use this type of structure in construction, the structure will collapse and large deformation will take place under any type of shocks or earthquakes. Second one is flocculated soil structure. It is mainly found in clays and formed when there is a net attractive force between different particles. The orientation of this type of structure is an edge to face as shown in the figure. It has high shear strength, low compressibility and high permeability. So this type of structure is formed when there is an attractive force between the different particles. Also the orientation is edge to face as shown in the figure. It is important to note that it has very high shear strength and low compressibility and high permeability. Third one is dispersed structure. It occurs in remolded clays. The orientation in this type of structure is face to face as shown in the figure. The shear strength and permeability are very low but have high compressibility strength. This formation of this type of structure occurs when there is a net repulsive force. In case of flocculated, we said when there is an attractive force between the particles, flocculated structure will be formed. Then in case of dispersed, when there is a net repulsive force between the particles. Repulsive means move away from each other. So when the particles move away from each other, when there is such a force present, this type of structure is formed. They occur in remolded clays, and in the figure it is clear that the structure is given in face-to-face orientation. The last one is cohesive matrix. On the other hand, in cohesive matrix structure, fine particles that are predominantly clay particles are in very huge quantity than coarse grained particles. Coarse grain appears embedded in fine grained and there is no direct particle to particle contact between them. So in the figure it is clear that the coarse grained particles, they are surrounded by a huge quantity of fine grained particles. Also there is no direct contact between the coarse grained particles. So such a orientation or structure is cohesive matrix structure. So in case of honeycomb, it is, as the name given, it resembles the shape of an honeycomb. Also if we use in structure, the structure may collapse and deformation will take place. While in case of flocculated, it is an edge to face orientation. In case of dispersed, it is face to face, and in case of cohesive matrix, the coarse grained are surrounded by a huge quantity of fine grained. Also there is no contact between the particles. So in the question, the soil is arranged face-to-face orientation. So this type of soil structure will be option number 1, that is dispersed. Now moving on to the next question. Which of the following statements are correct? Quick condition and liquefaction of saturated sands are based on similar phenomena. Quick condition is associated with only earth dams. Option 3, liquefaction is possible in dry sand also. And option 4, all of these. So let's discuss about what is quick condition and what is liquefaction. So if you look at the picture, it is in the first picture, it is shown the process of liquefaction. It is clear that it is a phenomena in which the strength and the stiffness of soil is reduced by earthquake shaking or rapid loading. While in the second picture, it shows quick condition. It is a condition when the upward water pressure gradient and the water flow reduces the effective stress. So in both the cases, the effective stress of soil is 0. So when the effective stress is 0, the soil will lose its strength and it will behave as a liquid. In the case of quick condition, the phenomenon of quick condition is due to the flow of water through soil, while in case of liquefaction, It occurs due to the vibration caused by earthquake, explosion or volcanic eruptions. So in both the cases the effective stress is 0. So they both are based on the similar phenomena. So the answer is option number 1. In the option 2, quick condition is associated with only earth dams. That is a wrong answer. It is not only associated with earth dams. In option 3, the liquefaction is possible in dry sand also. That is also wrong. Liquefaction, that process it happens in wet sand and not in dry sand. The notation SC as per Indian Standard Soil Classification refers to options are sandy clay, silty clay, clayey silt and clayey sand. So in this question, let's discuss about each type of soil. So if there is more than 50% of soil is retained on 4.75 mm sieve, that will be gravel soil. If the soil retained is 50% and that is on 4.75 mm sieve, it will be gravel soil. If more than 50% of soil passes through 4.75 mm and more than 50% is retained on 75 micron sieve, it will be sandy soil. And if the sandy soil contain more than 12% of fines with Atterberg limits above A line and plasticity index is greater than 7, it will be clayey sand. So if 50% of soil is retained, more than 50% is retained on 4.75 mm sieve, it will be gravel soil. If more than 50% of soil passes through 4.75 mm and more than 50% is retained on 75 micron sieve, it will be sandy soil. And if this sandy soil contain more than 12% of fines with Atterberg limit above A line, if the Atterberg limit is above A line, it contains clay. And if it is below A line, it will be silt. So here Atterberg limit with above A line and plasticity index is greater than 7. If you don't know the meaning or definition of plasticity index, it is defined as a range of moisture content over which the soil deforms plastically. So that is what plasticity index means. So if the sandy soil contains more than 12% fines with Atterberg limits above A line and plasticity index greater than 7, it will be clayey sand, and that is a notation SC as per the Indian Standard Classification. So the answer to the question is clayey sand. The next question number 4. The void ratio of soil sample is 1. The corresponding porosity of sample is. This is a very simple question and we use the basic equation, that is the relation between porosity and void ratio, that is N is equal to 1 by 1 plus E, where the value of void ratio is given as 1. So substituting the value 1 by 1 plus 1, that is 1 by 2. So the answer is 0.5. And moving on to the last question. A soil has dry weight of 15.5 kN per meter cube, specific gravity of 2.65 and degree of saturation of 72%. Considering the unit weight of water as 10 kN per meter cube, the water content of soil in percentage round off to 2 decimal places is. So in the question we have given the dry weight, that is gamma D, that is 15.5 kN per meter cube. Specific gravity, that is G, is given 2.65 and degree of saturation, that is SR or S whatever, that is 72%. Now and then given the unit weight of water, that is gamma W, is given 10 kN per meter cube. So we have to calculate the water content of the soil. So we should take the equation which contain all the terms, all the given terms in the question. So here the equation we used is gamma D is equal to G into gamma W by 1 plus E, where we have the value for G, gamma W and gamma D, and we will calculate the value for void ratio E, that is 0.7096. Now we will use the next equation, that is G into W is equal to S into E, that is, or we may say ESR is equal to W into G. So from that equation we will take the water content, that is equal to W is equal to SC by G. We have the value for saturation, void ratio and specific gravity. While substituting those values, we will get the answer for water content, that is 0.1928. Also note that we should write it in percentage with 2 decimal places. So the answer is W is equal to 19.28%. That is the last question. Thank you.